way of motion will not change. Like if it's traveling in a straight line, it won't be then traveling in a curvy linear manner after getting bounced by a polished surface. It will still be traveling in a straight line.
Yes,
Okay.
sir.
Then I said that light has got dual nature. Okay. The dual nature thing here is that in order to understand some of the phenomena for our convenience now, look here. At any given point of time, light will be traveling in a wave-like fashion and it will be having particles in it. But usually, if you were to look around, do we see the particles floating in the air? Huh? Wherever there's
Yes, sir.
illumination, okay, if there's a candle somewhere there that is lighted, or if there's a luminescent bulb, we don't see the particles there, but it is there. It is there. That particle name is photon particles. Okay, that particle's name is photon particle. PHOTON. Okay,
Yes,
now
sir.
so it is always there. But we humans, in order to understand some of the phenomenons, like for example, in order to understand reflection, the phenomena of reflection, we assume now we say that let's consider light as a particle in order to understand the phenomena of reflection better. Then for other phenomenons, we consider light as of having wave nature while we were studying it. Are you trying getting at what I'm trying to make sense of here?
Can you explain again?
Yeah. Look here. The thing here is that light travels in a wave-like fashion. It travels in the form of wave. Okay. But it also has particles in it. That is why I say that light has got dual nature in it. Right. Then I say that why I see it's having particle and wave nature. I'm saying that suppose if I were to understand the phenomena of reflection. So to study a phenomena of reflection, at that time, I will consider that light has got particle nature. I will say that I will having light as particle here. Just like if you were to bounce a ball from a ground, it bounces off from it either in the either at
Sir,
the same
so you
angle or
are
at a different
saying
angle.
that like the light is it scratches, it's just changing the direction.
Hmm. I'm saying that when you were to understand phenomenons associated with light like a reflection, thereby we consider light to be a particle, not wave. Remember that particle, okay? Then you have some phenomena in order to understand them in an efficient manner. At that time, we will be considering light as having wave nature. Are you guys getting it? Vaiga, Sundus, has Chakrika joined it or not?
Yes, sir. Got it. No, sir. Chakrika didn't join.
Okay. Right. And we see that the pathway of light gets blocked when an object covers the source of light, right? So light is when it travels, if it is being obstructed, then its pathway is getting obstructed here. Thereby light cannot travel further. So it is basically either getting reflected back, either absorbed into the surface somewhat. So either it will be absorbed or either will it will be reflected or other partial propagation of light will take place. Based on the visibility, we have got different types of substances. Like we have got what? Like we have got the opaque, translucent, and transparent substances, right? Out of the two,
Yes, sir.
which one will allow maximum passage of light across it?
What's it?
Out of opaque, transparent, and translucent, which object allows maximum of the light to pass through it?
Transparent.
Exactly. So transparent objects allows light to pass through them freely, completely. Example,
Yes. Sir.
what will be an example of transparent object?
Window.
A glass window, most importantly, right? So
Yes,
glass
sir.
window, right? But then glasses are also of different types. No, glasses could be translucent as well.
Yes, sir. For
The
translucent,
mirror.
so for translucent examples like butter paper, right?
Exactly. Okay, paper, which is usually a paper, a normal A4 size paper, can be made into a butter paper by applying oil over it. Thereby, it becomes a transparent. In fact,
Yes.
simple
Trans.
paper not being very thick, a simple paper not being very thick, it's also translucent. Right now, like
Okay.
normal paper, that is also translucent. Yeah, Sundus, you were
Yes.
saying a
The
plain mirror.
translucent is also an example of like aluminium foil, right?
No, not like that. Look here, an object which allows partial, partial, just partial amount of light to pass through it. So if light can pass partially, let's say only 50% of light can pass through a medium, then that medium is called as translucent. For example, as Vaiga said, butter paper, right? So butter paper, not
So
100% of the light passes.
frosted glass.
Frosted glass, very good. So frosted glass is also a very good example, right? Okay, and then Sandus, if you were to talk about plane mirrors, yeah, plane mirrors are opaque objects, neither transparent, neither translucent, because at the back of the plane mirror there's a silver coating, right? E.g., that is silver coating is there at the back of the plane mirror. So we count them in the category of opaque or just a piece of stone, or it could be anything, right? So on the basis of amount of on the basis of visibility, we have categorized objects into transparent, translucent, and opaque. Is that clear?
Yes, sir.
Okay. Then we did talked about reflection of light. Okay, have a look at this picture here. The dual nature of light. Light has both wave-like and particle-like nature, right?
Yes, sir.
So, for example, when you were to study phenomena like spectrum or web gear, that is a web gear, no? If you were to pass light through a prism, have you guys played with prism? Seen a prism? A prism, a triangular piece of glass. Yes.
I guess so,
Yes.
sir.
Hmm. So when white light passes through a prism, it disperses into its component color. White light is made up of what colors, guys?
What, sir?
White light is made up of how many colors?
The one.
Which one? How much?
White.
Seven colors. Seven colors.
I saw 7, right?
Yeah, seven colors. So white light is composed of seven different colors, and when this white light passes through a prism, it gets splitted into its seven color, like violet, indigo, blue, green, yellow, orange, red. You can count it: one, two, three, four, five, six, seven. Count it. Count the number of
Yes,
colors.
sir.
How many of them are? There are seven,
7.
right? So it's the same thing as the rainbow which you see. The
Yes,
rainbow
sir.
which you see, there also you get to see the seven colors of the light. So we can say that light is composed of how many colors, Sundus? Seven colors,
7.
right?
With George.
Right. So in order to understand a phenomena of formation of this spectrum, by the way, when you obtain this colors on a screen, on a piece of paper, on a piece of on a wall, on a piece of cloth, so thereby it is called as spectrum. Like you must have a surface to get this image now. You will be getting this
Yes.
image on a surface now. So
Yes, sir.
when we obtain the image of the seven colors of white light on a piece of paper or any surface, thereby we call it as a spectrum. क्या कहते हैं? We call it as a spectrum.
Okay, sir.
So in order to understand such phenomena, we have considered light to be having wave like behavior. So light is behaving like a wave here, right? Okay. In the higher classes, you will get to know about it in detail, like why the light is splitting into its component color. Mm. Like you guys know, why is it so? that red light is used as an emergency sign, or in traffic lights it is used as a sign to stop.
So I
Yeah.
think that red light is like very bright.
Vaika, what about you?
So I don't know.
The thing is now, red light can be seen from a distance. From a great distance, it can be seen. Okay,
Because it's like a
that's
dark color.
no. If that was the criteria, we would be using the black color. Huh? The thing
Oh
is
yeah.
that it
The
can be
in the
seen from
night,
large,
I think so. In the night, that this color like can go like very much bright.
very long. Okay, so this light, red light, can travel longer distances because it has got more longer wavelengths. Now, wavelengths, have you guys studied about it yet? I suppose not yet. Look, simple terms, may if I were to talk it in simple terms, in very simple way, I would say that red light will travel like this. See, while this violet light, now it will travel like this. It will
Okay,
travel
so
like this.
the other colors will stop at very short distance, while the long one like goes very like.
Exactly, exactly. That is the concept you have grasped it. Very good. Okay, now guys. So the thing is, red light travels more distances than the other lights. Thereby, it is used in the traffic lights or as a sign of emergency, so that the people are able to see it from a distance and avoid the accident. Getting it? So the thing is that
Yes, sir.
this figure, which I just this diagram, which I was trying to draw here, isn't that a wave-like fashion? Isn't it moving in a wave-like fashion?
Yes,
Right?
sir.
Yes, sir.
Right. Okay. And all the components of the light, orange, green, red, blue, yellow, all of them have got different wavelengths. Their wavelengths are different. Someone's wavelength is more, someone's wavelength is lesser, right? So in order to
Sir, in
understand such
all of the colors, red is the most brightest, right?
red is the most red is the one which travels the greatest distance. Talking
Very
about the
long.
talking about the brightness, if you have to talk about the brightness, then you have got colors like yellow, green, they are more bright. Okay, now. Hmm. Particle behavior. Okay, particle behavior in higher classes, especially in class when you get to class 11, there you will be studying about the particle behavior. Okay, but still, but don't get too confused about it. Look here, what basically happens now, whenever sun's rays falls on a material, okay, on a big material, whenever sun's rays will be falling, listen carefully, whenever the sun's rays will fall on a big material, suppose I'm having a very big material over here, okay, a large piece of material is over here, it could be any material, a piece of a huge piece of rock, a huge piece of metal. Whenever sun's rays will be hitting it now, whenever it will be hitting it, the electrons will be coming out from it. The electrons from the particle will be coming off. You know, any matter which you see in the universe, basically, all of them comprises of atoms. Yes,
Oh, yes,
isn't
sir.
it? True. Okay, then atoms, if you were to look it further under the electron microscope, you will get to see atoms also have atomic particles in it. Like, what are the subatomic particles present in it? Any idea?
What,
Like,
sir?
like atom, we know it is the smallest particle present in any substance.
Yes,
But then we say that inside atoms also there are subparticles. Subparticles.
like electron, proton, like that. Neutron.
Exactly, exactly. Electron, proton, and neutron.
Yes.
Right. So
So what
in the
Yes.
can you
high
say
class,
again?
electron, proton, and neutrons, these are the subparticles found in an atom. Like we say that atom is the fundamental unit of any substance. Just like we say the cells are the fundamental and structural unit of life. So we also say that the atoms are the tiniest substance present in any
So,
matter.
so can
Yes.
I ask one doubt? Like, water is made up of molecules or atoms? Like molecules, right?
Okay, what is the difference between the two? You should be asking. The question should be, what is the difference between the two?
Yeah.
Okay. The thing is that when we say, like the oxygen, if you were to talk about mm, oxygen, we either represent it as O or represent it as O2. Okay. So when
Yes, sir.
I have represented O here, it basically refers to one oxygen atom. Okay. But in nature, oxygen atom does not exist alone. It
Yes,
does
sir.
not exist alone. So it pairs with another oxygen atom. It will stay with another oxygen atom. So thereby, two oxygen atoms combines together to form O2. So here it was being called as atom, and when it combined, then it was being called as molecule.
Okay,
So
sir.
combination of combination of two atoms or more than two atoms is simply called as molecule, right?
Okay, sir.
It has to be of the same type. Okay. Oxygen, if it forms bond with nitrogen, then it will form another thing. So thereby you are having two different atoms now, oxygen and neutron, then not nitrogen. Then we won't call it as molecule. So
Okay, sir.
whenever we have got atoms of the same time which combine. Sundus, are you getting it or not? Sundus, your voice is not coming clear. I'm basically saying that not getting it. Look here. Let me repeat it over here. I am basically saying that what is all the components, what is all the matter in the universe made up of? Hmm. The tiniest bit, if you were to break a matter into millions and millions of the pieces, the tiniest bit that you will be getting is will be a piece of atom. Hmm. I have a wire here. I broke it into million pieces. The tiniest piece will be an atom. It has to be viewed under a huge microscope or an electron microscope. In that also I found out that so that is basically the atom here, right? So if you were to have an iron rod, if you were to broke the iron rod into millions and millions of pieces, right? So the tiniest piece will tiniest the tiniest piece will be called as atom here. Getting it now? Although it's not possible to break it physically, just to make it able to understand, I'm trying to say that if you were to break a iron rod into millions of pieces, the tiniest piece that we'll be getting will be an atom, right now. So if
Only the target.
Sundus, will you please repeat and please come closer to your mic?
I said only. I said only the tinier piece going to be.
Why? Am I only not able to hear her voice properly, or are you also not able to hear the
Yes,
voice?
sir. I'm also
I
able to
will
hear.
leave as well.
Okay.
I will leave as well.
Sundus, okay. She has left, then she'll be joining. Okay.
Yeah.
To you, I guess it clear?
Yes, it's clear for me now.
Okay. And then later on, there's a concept of compound also. Okay.
Okay, sir.
Right now. So compound is basically what? When two molecules or a molecule and an atom combines, then compound is formed like H2O, CO2, and O3, right? HCl. These are all examples of
Yes, sir.
compound where you have got combinations of different atoms: carbon, oxygen,
Yes, sir.
nitrogen, oxygen, hydrogen, and chlorine. Right now.
Yes.
Okay. Yes, Sundus.
I was saying that like the tiniest piece will only be the water.
The
You can't hear my voice.
um, will you please note down your doubt in the chat box? Okay, now please note down your doubt in the chat box, Sundus. I'm really not able to hear you properly. So there's some amount of background noise. Okay, note it down there and do let me know once you have written your doubt. I will be getting it from there. Okay. Now back to the chapter. What I was saying that why a
So I
different
said that. I said that. Like the tiniest piece will be the atom. Only that tiniest piece.
Mm-hmm. Yes, Sundus, I'm really sorry, but really I can't hear you properly. Your voice is really not coming properly. Why is her voice coming now properly, or like I'm having some
Sir,
issues
I'm
in my
also not
connection?
able to hear, sir.
Okay. Sundus, why don't you just write it in the chat box? Please write it in the chat box. I will be getting it from there. Okay.
So now you can.
Yeah, now somewhat better. Yeah, please speak again.
I said that the tiniest piece of that thing will be the atom. Like not the bigger piece.
I'm terribly sorry, but I can't understand what
So
you're
you can
saying.
hear me now.
Yeah. Please, like the room which you are sitting at, now please get out
So
from
I
there.
am sitting in the
Move to a
quiet
quieter
place.
place. Please
I
move
am
to a
sitting
quieter
in it,
place.
sir.
Okay.
There is no one around.
Okay. Okay. Now again,
Sir, can you hear me?
yeah, here you a little bit.
Okay, sir. So I asked that like the tiniest piece will be the atom, not
Yeah.
like the bigger pieces of it.
Hmm. Hmm. Exactly. So the tiniest piece of any matter will be the atom. Okay. You get any matter in any form, whether solid, liquid, or gas. The tiniest bit of that matter will be an atom. And inside that atom also there are subatomic particles like protons, neutrons, and electrons are there as well. Okay
Sir,
now.
10 protons and 10 electrons and 11 neutrons, right?
No, not necessary. That
Oh,
depends
yeah.
on the type of element you have. That depends
Oh,
on
yeah, sir.
different atoms. Okay.
Like proton would be plus and electron would be a minus, right?
Yeah, that is correct. Proton is having positive charge, electron is having a negative charge. Neutron is having a zero charge on it. Okay. From atom to atom, the number of protons varies. Okay. And protons number will always remain fixed. You will get to know that in later classes. Okay. Not going there, otherwise, it
Okay,
will
sir.
be then confusing for you guys to understand it right now. Okay. So the simple thing is that is atom. And when two atoms combine together, for example, one oxygen atom, another oxygen atom, both of them, let's say, let's do partnership, let's combine together, then it forms O2. Okay. We write 2 at the base of O here. So thereby, at this moment, we will be calling it as molecule. And when they were separated, then we were calling them as atom here. Getting it now? Okay then. If that is clear, we shall move ahead then. Clear?
Yeah.
Okay. Now, where we were at. So we were talking about reflection of light. So we can define it
We
as,
finished that, right?
we have finished that, no? And
Yeah.
we were talking about concave mirror convex mirrors as well. Okay.
This one was finished.
So this was finished, but
Yes.
one interesting thing was left here. Okay. Look here. If you can see this image here, it's a very good representation of how lights are getting reflected from a plane
Yes,
mirror.
sir. It's
Look
bouncing
at,
back.
it's bouncing back, guys. And also, okay, it is coming in this manner, this manner, this manner, and then getting, sorry, yeah, stay here, and then getting reflected back like here. Okay, then look at the second rays. It is coming here and then again getting reflected back in this manner. Okay, now they are forming some angles with the mirror. Okay, some angle will
Yes.
also be formed between the incident ray and the reflected ray, right? Okay, now. So in later, just after a few minutes, we'll be talking about in what manner the incident rays and the reflected rays get reflected. I mean to say that what are the laws they are following while they're getting reflected from the plane mirror. They will be following some laws in here, right? Okay.
Yes, sir.
Then what is an image? We basically understood that. Okay, inverted image of a candle, as you can see here.
Yes.
Okay, the next thing which we are going to talk about, the nature of image. Hmm? So images formed are also of different nature right now. Like in a spoon, you must have seen your inverted image of your face. Yeah, you will observe that
What's up?
in a spoon, you get to see that the image of your face is inverted
Yeah, like yeah, sir. Like
on the front side of the spoon, which is bent inward.
yes, sir.
Okay, so thereby you will get to see that the image of the face is inverted in there. While on the
Yes, and we also get like the calm water, right? It gets reflected
hmm,
when we
hmm,
look into that.
hmm. Calm water, but that gives you not inverted image. That's upright image. Okay. Hmm.
Okay, sir.
So before that, before we even move about talk about the images now, let's quickly revise the different types of mirrors. So mirrors, how do we define it? We generally define it as any shiny surface that can reflect back light.
Yes.
Okay. So any shiny surface that can reflect back light. Okay. So we see that um, there are so many polished surfaces and offices and buildings and schools that also reflects back some amount of light, and we also see our reflection in that polished surface. So that also sometimes acts as a mirror, right? And the mirror which has got a plane surface, that will be called as a plane mirror, right? So a mirror having a plane reflecting surface, having a plane reflecting surface. So that will be a plane mirror. And then you will be having the curved mirror as well, which we did talked about in the previous class. It will be either bent inward or bulging outwards, right? Okay, then.
Yes, sir.
Now here you can see an image, mirror here. Okay, so that is a curved mirror here. Getting it now? So what type of curved mirror is there? It is a concave mirror or a convex mirror. Hmm. We
Yes,
will
sir.
get to know about them in a moment here. But let's do
Okay.
talk about the nature of images first. Okay, let's start talking about the nature of image from the plane mirror. Then we will come to the curved mirror. Then, right? Okay. So have a look at the plane mirror. What are the things which we can say about the image of this candle form in the mirror? First thing is that it appears upright. It's erect. Okay.
Yes.
So play nature of image formed in a plane mirror. So first thing that image is erect. Okay. Then the second thing is that if you were to stand in front of a mirror and then if you were to raise your right hand, then in the mirror it appears as if you are raising your left hand, right? So this
This is
has
about
been
the plane mirror, sir.
about the plane mirror. Yeah. This has been called as the lateral inversion of the image. What did we call it as? Lateral inversion. So images in the plane mirror are laterally inverted. Okay. Okay then. Now, if you were to look at the size of this person in the mirror, what do you think? Is it of the same size or is it smaller than it or bigger than it?
Same size.
Same size. So the third point about it is that image is of the same size as of the object. The images are of same size as of the object. Now, suppose someone's height is 6 feet. Okay. Now, someone's height is 6 feet, and that person wants to get a full body image of his in the mirror. Hmm? My question to
Okay.
you guys is that if someone's whose height is 6 feet and he goes to the
Yes.
market to buy a piece of plain mirror, and he asks the shopkeeper to give me a mirror in which I will be able to see my full body image. So what should be the minimum length? What should be the minimum height of the mirror he should purchase? Should it be? Let me give you the options then. Should
Okay,
it
sir.
be? Mm, Sundus understood the question.
Yes, sir.
Okay. So should he go for a 3 feet mirror, a 6 feet mirror, a 12 feet mirror? Okay. Or a 1.5 feet mirror? Mirror of
So
which
Like
size he should be
6
opting?
feet.
6 feet. 6 feet.
No. Think again.
So 12 feet.
12 feet.
Hmm?
12
12 feet.
feet.
No. It will be the 3 feet. Just
What,
half of the
sir?
height.
Seriously?
Yeah. He will have to purchase a mirror of 3 feet. So the principle here is that now, in order to get a full body image, we need a mirror of the half size of the body. Getting it
Okay,
what I'm
sir.
trying to say here. Okay.
Yes, I
But then
got it.
also, it's not like the person is standing here and you will put the mirror at the face of the person like this. No, it has to be
No,
put
sir.
at the proper distance as well. Okay, now. So in
Okay,
order
sir.
to get the full body image, you need the half of the length of the mirror. Then now, question is that suppose someone is running towards a plane mirror. Okay, he is in a hurry to get his image. Okay, say that he is running towards this mirror at a speed of, let's say, 5 meter per second. So the thing is, at with what speed his image will be running towards him? Mm, yeah.
What, sir?
Hmm.
Yeah, so the same. 5
No,
meter per second.
no, no. That is
Hmm.
also an interesting thing here. Let me give you the option. Option number A is that his image will be running towards the person with a speed of 10 meter per second, or 6 meter per second, or 15 meter per second, or let's say 18 meter per second.
So the first option 10 meter per second.
10 meter per second. Getting it now?
Yeah, for like running, you can get like more this size. Okay.
Hmm.
Like
Okay,
that.
sir. So,
So simple thing here is that if your body is running towards a mirror with a speed of x meter per second, then the image will be running towards that person with a speed of 2x meter per second here. With an example, it will be 5 meter per second, and then the bot image will be running with a speed of 10 meter per second. Getting it?
okay, sir. Yes, sir.
Okay.
Got it.
So these are some interesting things. Try to remember that. Okay. Okay. And the back of the plane mirror, we use coating of which metal? At the back of the plane mirror, usually coating of which metal is used?
Uh,
Like Mhm.
I don't know, sir.
if you were to scratch the back of the plane mirror, earlier it was silver. Earlier silver was being used, right now,
I
but
guess
now it is Mhm.
iron.
not iron. No, not iron,
Okay.
not iron.
Okay.
But now it is different components are used. Okay, and then you will be seeing that there's a red paint applied over the back of the plane mirror. If you ever happen to see that. Okay. Hmm. So other thing here is that distance between the distance between the image and the object from the mirror always remains same. So suppose this person here is standing, let's say this person here is standing at a distance of 5 meter. Standing at point A, he's standing at a distance of 5 meter from this plane mirror. This is a plane mirror here. So the where will the image of the person will be? Will it be at 5? Will it be at 6? Or will it be at 7?
5, sir.
5, obviously. Right. Okay. So it will be at 5 meter. His image will also be at 5 meter. Right. Okay.
Yes,
So the
sir.
distance between the image, distance of the image and the object from the mirror remains same until and unless the body changes its position. Okay, so we see that the distance between the image and the mirror and the object and the mirror always remains the same. So let's note that point also. That point I'm noting down here. Okay, now. By the way, have you guys been taking notes of the class or not? In
Yes,
other
I'll take
classes,
screenshot.
screenshot. After the class, make sure you note it down. Vaiga,
Yes,
you
sir.
take the Sandos, you take the notes or not? I might ask for the
Yes.
notes anytime during the class. Okay.
This message or message.
Yes, I underline the points on my textbooks.
Okay, good.
Sir, it's
On the
better that you ask
textbook,
these method notes because I didn't bring my like the old book.
yes, you are.
Okay, fine, sir, nothing.
Okay. No, no. But by the way, you're audible right now. You're audible.
No, sir, nothing.
Okay, okay. So the
So
next
we
point is that
finished. So we finished plane mirror.
no, no. Just let me
Okay.
write it down. The distance between the image and the plane mirror and the distance between the object and the plane mirror always remains same. And the plane mirror remains same. Okay. So that is another point. Or if you were to increase or decrease the distance between the object and the mirror, the distance between the image and the mirror also increases or decreases, right? So if the person is standing over here, if you were to move forward, the image will also move forward, right? So if you were to
Can sir, can you repeat the point?
Hmm,
I didn't
I'm
hear.
s- I'm saying that if I were to decrease the distance between the person and the mirror here, so the distance between the image and the mirror will also decrease right now. Or if I were to move this person away, so suppose earlier it was at a distance of 5 meter, now it's at a distance of 15 meter from the mirror. So the image will also move away 15 meter right now.
Yes, sir.
Yes.
Okay, so that
So
is the basic. That is the basic thing. Okay. All right. Now, in some of the cases now, like all the while we have been talking about the images in the case of a plane mirror, right? So we saw that in every case, an erect and upright is being obtained. It is laterally inverted. Images are of the same size as of the object, right? If you were to move at a speed of 5 meter per second, if you were moving towards you with a speed of 10 meter per second, in order to get the full body image, you need to have the half size mirror of your body. Then further thing is that can we obtain the image form in a plane mirror on a screen? Is it actually there?
what, sir?
I am saying that suppose is it possible like if someone is standing near a mirror, that person moves away from the mirror, that person has walked away, but his image still remains there.
Sir, it's not possible.
It's not
Not
possible,
possible.
sir.
Not possible, right? So it's not real. So we see that the image that is formed here, it's virtual in nature. It not actually
Sir, it's
stays there.
possible. if like that person is ghost.
Yeah, unless and until if the person is ghost. Okay. Hmm. So the image form is virtual in nature. Image form is virtual. Getting it? So these were the
Yes,
different
I got it.
properties of the images formed by a plane mirror. But then you will be having images form in mirrors like this. See this image here. You get to see that the image form of the candle is inverted in nature, and
Yes,
it's upright down, inverted.
yes, sir.
Okay. So then in some of the images you will get to see that it is inverted. Okay, we will come to those mirrors in a while, but let's understand about this ambulance. Any guesses why this ambulance later is spelled backward and in inverted manner?
Because like I think there is a mirror so that like I can see that ambulance like
Yes, sir. Like it's a mirror image.
another.
Hmm. Mhm. Like write something on the piece of paper in an inverted manner, right?
Yes,
For
sir.
example, write like LE
So I've
F.
tried the experiment of like
Mhm.
putting it in like a glass that right, so it is showing like right the correct spelling of right.
Exactly. For example, if left is written here, if you were to write it like this manner, okay, so you will be seeing the image like this in the mirror right now. So that will be
Yes,
the
sir.
mirror image, right? So thereby, the the vehicle that is ahead of this ambulance, in his or her rear mirror, he will be seeing the ambulance like this, right now. Thereby, ambulances are written from left to right and in an inverted manner, right? Left to right inverted, not the upright. Okay, left right inversion is um in we are writing it in left right inversion. Getting it?
Yes, sir.
Okay. Now talking about the mirror in general. In general, what do we see? In general, we see that the image formed by the mirror is always left right inverted, right? So this means that the right side of the object appears as the left side of the image, and the left side of the object appears at the right side of the image. Simple, right? Okay.
Yes, sir.
Then you will have examples of curved mirrors where you will be getting to see the images which are inverted in nature. That's an inverted image of a candle. Okay, so whether it will be in curved concave mirror or the convex mirror, that will be discussing later on in the chapter, right? Okay,
Okay, sir.
right now let's just stick to the plane mirror, because the inverted image, that concept is of the curved mirror, but right now we will be talking about plane mirror only, as we have to discuss about the laws of the reflection in plane mirror, right?
Okay, sir.
Okay, then you see this is a very smooth and polished surface, okay, and on which light rays are falling. Okay, but then remember, the thing is that at any given point of time, it's not just one light ray that falls on the piece of mirror. There's a number of light rays. So many of light rays are falling now. Have a look at this image.
Yes.
Yeah. So here you can see. Is it just one light ray falling over it?
No, sir.
No. There are so many. I know. Right, Sundus? So for having convenience, for the purpose of convenience, we just take one light rays. Okay. By the way, who will tell me why we have called it as ray and not line segment? Or why don't we just simply say it as line? Why call it as incident ray? Why not call it as incident line segment or incident line?
Line segment is like sir, it starts but it ends like,
Hmm. Hmm.
and the line is like continuous. It's not like never
Hmm.
stop. It's like infinite,
Very good. Very good.
endless.
So the ray means the direction of path in which light is traveling.
No. Look here.
The ray has a starting and it has a stop.
Exactly. In mathematics, in the chapter,
Line and segments we have learned.
exactly, in that chapter, you must have learned that, for example, if you have were to have a torch here, so from the torch, the light rays are coming out. So it has got a source now. Okay. So we say that it's coming from a point source here, and then moving in a one direction infinitely. Okay, it moves in one direction infinitely, and it has a source of origin right now. So usually in mathematics class, you must have represented a ray like this: a point from where starts and a arrow pointing its direction, the direction in which it infinitely moves. Getting it, Viger?
Yes, I got it.
Okay, line and line segments are clear. A line will continue to extend on both sides endlessly. Well, if you were to get a segment out of it, that is simply line segment. Okay, back to what we were discussing. Okay, now incident ray. Incident is nothing but the light rays that falls on the mirror. That simply falls on the reflecting surface. That is the incident ray. Then the reflected ray is basically the ray that is getting bounced back from the reflecting surface. And the normal is nothing but an imaginary line that is drawn perpendicular to the reflecting surface. Okay.
Okay, sir.
Now, at any given period of time, whenever reflection will be taking place, whenever there will be a regular reflection from a smooth surface, like a piece of plain mirror here, then you will get to know here that the angle formed between the incident ray and this normal, and the angle formed between the reflected ray and the normal, they will be always equal to each other. Therefore, we said that angle I is equal to angle R here. Okay. You know how do we represent angle? Just rather than writing as I and R, we can say it's angle I equals to angle R. Okay. Angle ko hum, we represent angle in this with this symbol, right? No?
Yes,
Angle is represented.
the map
Yes, sir.
ma'am explained it.
Right. Good. So notice the term I said, it's a regular reflection. Whenever there will be a regular reflection, then light will be following certain laws. Now, do you know what is regular reflection and diffuse reflection? I suppose it is clear. Huh? Diffuse reflection, what is it? Suppose I have a bumpy surface like this, huh? Like this, or a smooth and shiny surface like this. So light rays will be falling in this manner and then getting reflected in this manner,
Yes,
right?
sir.
But here the case will be just opposite. It will be coming in this manner, but the manner it will be getting reflected, it's not fixed. It might be like this, or it might be like this. Okay, might be like this. Getting it? So thereby,
Yes, sir.
that is an example of diffuse reflection, and this one was an example of regular reflection on which certain laws will be applying. We are about to discuss that law. Have a look at the image here. You can see the regular deflection and irregular deflection. Look at it for a few seconds. See how the rays are getting reflected. Okay. Shall we move
Oh,
ahead then?
yes, sir.
Okay. If I were to ask you laws of reflection, which we will be discussing, it will apply on which figure? Figure number this or figure number A or B?
B.
Figure number A. Yeah. So on B, it won't
Yes, sir.
be applying. Okay. Now, if I were to say that incident rays are always parallel to each other, I'm saying that incident rays are parallel to each other. Parallel, you guys know, when the lines do not cross each other, do not intersect each other. That is
Yes,
parallel.
sir.
So which images will be true? Which figure will be true? Hmm. It's not erasing. Like, anyways, so if I were to say that light rays are parallel, in which case A or case B, incident rays are parallel.
So can you repeat the question? I couldn't hear that.
My question is that I'm saying that incident rays, the incoming rays are always parallel to each other. So I can see that in either figure A or in figure B, or can I see that in both the figures?
So I guess it's A.
No, Sundus, you need to observe the figure closely. Let me highlight the incident rays, then it will be convenient. Look here. I'm highlighting the incident rays. This one, this one, this one. These are the incident rays, right? Okay, and in this figure, this one is the incident ray. Okay, and then this one is the incident ray. Just take these two, this one and this one. Okay, suppose the light rays are falling on it. Okay, what do you think? Guys, are the rays in both the cases not parallel to each other, these incident rays? Yes. Sundus and Vaiga, I'm saying that are the rays that are the incoming light rays not parallel to each other in the both cases, whether we talk about the diffuse reflection or regular deflection, whether you talk about regular deflection or irregular deflection, are the incoming light rays not parallel to each other in both the cases?
Sir, can you explain again?
My question is that are the incoming incident light rays not parallel to each other in both case A and both and B, in
So
both
in
the
A
cases?
it's not. So in A it's
Yeah.
parallel and in B it's not parallel.
Sir, A, how is parallel?
Just
It's reflecting, right? How
just
it
look.
is parallel?
Okay, let me explain. I will be explaining that. Just look at these two rays which I've drawn. Don't look at the exact figure. Just look at these two rays which I've drawn here.
Was so
If I were to just look at these two rays, do they seem to be intersecting each other? Huh? Do they not appear to be parallel? Are the distance between the two not equal? Vaiga and Sundus. Have a
they
look
are
at
not
figure number.
parallel, right?
Yeah, they are not parallel.
How come they are not parallel? Look here.
Sir,
These
like they have to intersect their points. No, that's why.
no, you're getting wrong there. When two light rays crosses each other, then they are called as intersecting lines. Now we call them as intersecting lines. If the light rays never intersect each other, then we call them as parallel lines.
So both A and B are parallel.
Both A and B are parallel. Both of
Okay.
them are parallel. Sundus, is it clear? Are you getting it? Sundus?
Yes, sir. Sir, like the first one, it's a reflection, right? But still it is parallel. Okay, sir, I got it. Like the four lines are joining, right?
Mm. Like
Like that?
Mhm. Like whether you hit the torch light on a rocky and bumpy surface, or whether you hit the torch light on a plain mirror, the incoming light rays from the torch, they are in a straight line now. They appear to be parallel to each other now. They does not change the direction now. So the torch light, imagine you're having a torch in your hand. The light rays that are coming from it, they are coming from it in it like this, somewhat like this, right? So they appear to be parallel to each other now. Okay, but then someone will say, so the torch light comes in this manner, no? In this manner. I'm saying that just consider the middle ones like this. Okay. So the incident rays, no matter whether it falls on a rocky surface, in a bumpy surface, or whether on a smooth and shiny surface, they will always be parallel to each other, irrespective of the surface they reflect with. Is that clear or not?
Yes,
Yes.
Okay. So note that down somewhere, that incident rays are always parallel to each other. Okay. And then after, we have got the concept of the laws of reflection. What are the laws of reflection? Okay. So hopefully we will be trying to complete cover that in the next class then. Okay now. So we'll be
Okay,
talking
sir.
about the laws of reflection. Okay. Meanwhile, revise whatever we have discussed so far in the class.
Okay, sir.
okay, sir. Thank you.